Hello everyone, today I have a very interesting video. The production process of small hydraulic pumps in a mechanical workshop in India. And the special thing is, they do it completely by hand, no CNC machines, no automatic pressure testing. Sounds a bit reckless, right? But if you look closely, you will see that this is a story between cheap price and durability, between manual experience and standard techniques. And I want to dissect with everyone. Doing it this way, should we trust it? Don't forget to like and subscribe so you don't miss out on future in-depth analysis videos. At this point, I have to say I was really scared. You see, they are attaching the shaft to the pump body, using only their bare hands and a rubber hammer to hit each stroke. There is no hydraulic press, no centering bracket, no force measurement or parallelism check. In the hydraulic engineering profession, especially rotating parts like the pump shaft, just a little deviation can cause immediate harm. Let me give an example to make it easier to understand. If the shaft is installed incorrectly, the rotating shaft will vibrate, and vibration will break the seal. Oil leakage is certain, and if it is serious, it can burn the pump, damaging the entire hydraulic system behind it. I have been in this industry for more than 10 years, and have handled several cases like this. The result is that it takes a whole week to fix, not to mention having to replace the seal, replace the shaft, flush the oil, and clean the entire system. So when I see this hammer installation scene, I feel both sorry and worried for the end user. Has anyone here ever knocked the shaft by feeling? Has anyone ever encountered a situation where the pump was installed with the wrong shaft and caused serious damage? Or if anyone has a tip for installing the shaft correctly without a press, please share it. Maybe you can learn more. At this point, I really regret it. This is the shaft turning stage, a very important step when machining hydraulic pumps, but look closely. The lathe is an old model, running on mechanics. There is no gauge to check the runout. I also don't see the worker remeasuring the dimensions after finishing the turning. Even if it's only 0.01 millimeter wrong, it will affect the joint. In the hydraulic engineering industry, the rotating shaft is the heart of the pump. It determines the stability of operation, and at the same time, it is also the place where errors are most likely to occur if the machining is not standard. What are the consequences if the shaft is misaligned or not round? When rotating, it will vibrate. The vibration will break the seal. The seal is broken, oil leaks, the system loses pressure. If used for a long time without detection, motor burns, shaft jams, the whole machine breaks down. I once inspected a press system. The error was only because the pump shaft was misaligned by exactly 0.03 millimeters. As a result, the customer lost 3 days of stopping the machine, losing more than 100 million, because each hour of delay in the line is a lot of money. I feel like they work very quickly here, probably to save time and increase production. but there are almost no standards in the inspection process. If it were you, would you dare to use this type of shaft to install in a high-pressure pump system? Or do you think in which cases this type of pump can still be used? Those of you who work in precision mechanics will probably have many opinions. Feel free to share in the comment section. I really want to read more. I was quite surprised to see that this was the final test step. Simply turn the shaft by hand, rotate it a few times, and then tilt your ear to listen to the sound. No pressure gauge, no flow test, no vibration sensor, no temperature measurement, no accompanying charts or reports. I think their goal is just to check if the shaft can rotate, if it is stuck or not to check if it operates accurately, stably, and meets technical standards. In industrial production, especially hydraulics, the test, inspection stage is extremely important because this is where the product is shown to be reliable. A hydraulic pump not only needs to rotate, but also needs to, achieving the correct design pressure, no pressure drop, no oil leakage after many hours of testing, stable operation under load, no vibration, no unusual heat. Here, I don't see any load simulation. I don't see any testing in a real working environment. Just turn your hand, listen. A kind of intuitive test. Literally, if it runs, it's okay. So I want to ask you guys a real question. Are you willing to buy or use a product tested in this way? Or for you, industrial products must have a methodical testing process, with data, with certification. For the cheap domestic market, it is acceptable. But if brought to the international market or applied to systems that require high reliability, I think this is a very sketchy testing step and has great potential risks. To be honest, I really admire the skills of the workers here. They work in poor conditions with old equipment, but can still produce finished products. They do not use high-end measuring machines, do not have automatic production lines, but still know how to process, assemble, and test with their own experience. Such skills are valuable, not available everywhere. But the problem here is not, can it be done or not? But, making a pump run is easy. But making hundreds, thousands of them run stably for a long time is the difficult problem. Especially in industry, where uniformity, accuracy, and reliability over time are required. To put it simply, you can use a cheap hydraulic pump, install it in the machine, run it for a few months, and then replace it. Or you can choose a genuine pump, expensive, but runs smoothly, does not damage the seal, does not cause the machine to stop. Each person will have their own criteria. Small-scale mechanics prioritize low prices. Large-scale factory operators need higher stability. What about you? If it were you, which option would you choose for your system? Manual pump, easy to replace, easy to repair, low price? Or standard industrial pump, more expensive, but safe to operate? Comment and share your perspective. Whether you are a mechanic, an operating engineer, a business owner, or a technology enthusiast, I would love to read more opinions from many different perspectives.